All right, assalamu alaikum everybody. I hope you all are doing super duper well. So will you share today's notes? Of course, I can share the notes if you guys want it. I'm going to share everything, don't worry. Okay, so the recording will be available, the notes would be available. Don't worry, everything would be available. So we just have 2 more minutes before we officially jump into the course content. So let me know if you have any questions so that we can quickly address those, and uske baad we can jump into the course content then. So will you be giving IGCSE papers? This syllabus is for both IGCSE and O-level. So whether you're appearing in IGCSE exam or with the O-level exam, it makes no difference at all. Likewise, guys, if there are any questions you might want to ask from me in the first 2-3 minutes, I'm giving you the chance before I turn off the chat box, because then, of course, there will be a large influx of students. So, you know, right, kuch bhi ho sakta hai. So we don't want to take the risk. So will the notes we send today for the ones? Yeah, it's going to be sent for everybody. Don't worry. Walaikum assalam. Walaikum assalam. Any other questions? Walaikum assalam. Walaikum assalam. I hope you all are doing super duper well. So when you will give the LMS access, once we have finalized the registrations and this demo period is ended, we're going to then provide you the access to LMS. So the way I stated yesterday, you'll be given access on both the Conceptuals website and at the same time your Google Classroom. So the registration number is not responding. Oh no, Ma'am Naiba will be responding. It's just because a lot of students are again and again reaching out to her for registration. So, you know, like it's being spammed up. So don't worry, she's going to get in touch. If she does not reply back to you till tomorrow, you may just send a reminder and she's going to get back to you. So should you take coordinate science or physics as an extra subject? Well, if you haven't studied physics, I would say physics is a good subject. You should study it. So how many classes will there be in a week? 5 classes, 1 hour each. Inshallah, Monday to Friday. Any other questions? We're going to take 2 to 3 more questions before we start. So how do I pay for the courses? So basically, you can pay through, I don't know, Ma'am Naiba will share the method, but you can do bank transfer. You're like multiple ways of paying. So वो तो easy, मसले की बात नहीं है. Whatever is, or you need to do it like online, okay? It's not like you're gonna give us some sort of physical cash. But yeah, any other question? So should we practice topicals on our own when we finish a topic? That is something I'm going to come to when we are done with the topic. Okay, so once you all register with us, I'm going to, inshallah, craft and share that ideal crazy plan you need to ensure to get that A star. Okay, so that plan is going to include everything you need to in order to, you know, cook your exam. So sab ho jayega, don't worry. So should I take a notebook? वैसे रखनी है रख लो. Again, it's not like I'm someone who is going to make you write every single word. So can we get a distinction? Of course you can get a distinction. If I got a distinction, you guys can get a distinction too. Sab ho sakta hai. So don't worry. So how to retain memory of everything. Abhi aap samjho, listen to everything. Jo cheez samajh na hai, usko, uske baare mein questions पूछो, and then afterwards revise the notes which I share with you. Maybe jot down the important points after the class, okay? And uske baghair, I would say, solve topicals. The more you do practice questions, the better your performance is, inshallah ta'ala, going to be. All right, so a good amount of questions have been addressed. How hard is it to be the top in your country? Good question. You need to be the top 1%, right? Or maybe even lower than that. But yes, we do have a lot of students joined in. So let's start off. And assalamu alaikum, everybody. I hope every single one of you is doing super duper well. We're inshallah ta'ala going to be officially starting off with the course content today. This is the demo class number 2 for the IGCSE and O-level computer science classes at Conceptuals. For anybody who might have missed the first demo class, don't worry. We didn't cover any course content in that. It was just an overview and an introduction into how the course would be carried out. So you can watch the recording that is available on our YouTube channel. If you're unable to find it up, just let me know, text me in the group, and I can reach out with the recording to you. So don't worry, everything will be perfectly fine, inshallah. But yeah, it's officially time we jump into the course content. So before I start off with the syllabus, I wanted to ask this one question from you all. Have you ever wondered this iPad, this laptop, this computer, or this mobile phone, which you might be using at this point to take this class, how does that work? Have you ever wondered how, if I say that I have a phone with me, it may seem like, okay, this phone is, something very crazy, that it sort of has everything and it's working perfectly fine. But have you ever wondered, how does a computer work? We never get to understand the basic fundamentals, right? But you know what? It's very simple. Your computer is literally made up of switches. What's a switch? So look up here. Have you seen something like this in your homes? Definitely you would have seen something like this, right? This button, of course, it's everywhere there. And what is happening up here? A person is turning on a switch and turning off a switch. For instance, if I have my light in front of me, I may turn it over. Where's the lamp? Okay. So I might turn it off. So you see, I turned it off. And then I can turn it on. So what's apparently happening? This is basically trying to tell us that, okay, there is a sort of a switch which can either be turned on or off. But the best part is that, you know what, that all these technological devices which we have, whether they're computer, mobile phone, tablets, or whatsoever, they're made up of something very similar to this light switch. And we call that thing as circuit. So you might have seen such animations the way you're looking up here, where you have like these multiple computer components coming up from here and there, and interconnected with each other. And you might be wondering, okay, sir, that's some like complex stuff coming up here, and I don't know what's happening. But in reality, everything which you see up here, or when you open up a computer, is nothing but a plain circuit. And a circuit is nothing but something like a switch, which could either be turned on or it could be turned off. So the point here to understand is that if I break the bigger chunk of computers into very minute components, the smallest part of our computer is something known as circuit. So a computer is basically made up of different thousands level of circuits, and all those circuits are basically joined together in order to create what we have today as a laptop, to create what we have today as a mobile phone, to create what we have today as a tablet. Okay, so ये बात तो ज़हन में understand कर लो. First and foremost thing, that the most fundamental thing which builds your computer is what? A circuit. And now this circuit is the same as the one which you study in physics and the one which you have in your homes. It could either be turned on, the way we can see that when it's turned on, the light is as yellow. But the moment he turns it off, the light goes off. Similarly, your computer also has thousands of such circuits. They're joined together and they're told that, okay, bro, when you turn it on, you do something. When you turn it off, you don't do something. For example, on my keyboard, have you ever wondered how does a keyboard work? Have you ever wondered how does a keyboard work? Your keyboard basically is a combination of different circuits. For example, there is a key which has M on it. So generally, as a person, if I want to make use of the keyboard and I, let's say, want to type M, I'm just going to do what? I'm going to press that M button. But because you guys are now the cool students, the students who study computer science, the students who come up with the intention of cooking the whole world, we need to understand the logic behind what's happening when I click that M button. So in reality, when computer programmers were trying to create this up, the way they were thinking was that if I click this button, what's going to happen? So at the back end, you know what? They sort of created an electronic circuit. They were like, okay, let's create a circuit. And the circuit would be like, when the person presses the button, you should basically type M on the screen. And if you're sort of not pressing the button, you should sort of do nothing. So you should just be like, okay, let me ignore it. I'm doing nothing. But the moment a person presses that M button, it's similar to saying that if I have a light switch, I turn that on. And likewise, your whole computer operates on the same model. You have thousands of such switches, whether that's my mouse click, whether that's my keyboard typing, whether that's double clicking on my computer, whether that's if I have my phone and I'm swiping up here this way, you see, if I let's say my phone, I want to open it up. I did this and okay. So you see, I can have my password pipe in up here, right? But what's happening? Every touch is a circuit built within the computer. The moment I click on something, the moment I swipe the screen or do whatever, my computer processes it as a circuit where one action could lead to doing something and the other action could not do anything. But for a human like me, I could either say that, okay, if there is a light switch, let's go back to the light example. I can say that the light could either be on. So like, for example, if I have a light bulb in front of me, I can say that either my light would be turned on like this, or the second way is that I don't have a light turned on, right? So we only have two cases. Either you have the light or you don't have the light. But now this is something we humans can understand, right? Light hai ya light nahi hai. Ya pe main bolu ke like the way light just went off, right? Light went off. So I'm like, okay, light chali gayi. But your computer does not understand that, okay, light chali gayi. How does your computer process it then? So your computer always says that if something is on, it gives it, sort of a mini keyword. जैसे मैं बोलूं ना कि okay, you guys prepared a lot, so I gave you the keyword A star. That anybody getting an A star is equivalent to saying that this person literally aced their exam. Similarly, what your computer did was that with every circuit, the moment your circuit was on, computer would be like, okay, it is going to have the value of 1. And the moment it was off, it's going to have the value of 0. So like conventionally, when we normally say, okay, the light is turned off. So your computer does not think that the light is turned off. The computer is like, okay, the circuit has the value 0. And likewise, when I say that a circuit has been turned on, we say that the computer is saying that the circuit has the value 1. So next time, if I have to talk about whether a computer circuit is turned on or it's turned off, we talk in terms of two things, either 1 or 0. A 1 indicates that a specific circuit is turned on. So like, for example, if I press the M word on the keyboard, if I press this up, it's not like my computer is going to think that, okay, I've pressed it up. No, the moment I press it, my computer will be like, okay, this whole thing, whatever was at the back end, whatever like the coding was done, whatever the programming was done, it is going to be sent a signal of 1. It's going to be told that, okay, it has the value 1, which means that, okay, bhai jo bhi bande ne socha tha na coding shooting karte waqt ki yaar, okay, when this is being pressed, aapne screen ke upar ye kar dena hai. Whatever was being thought at the first place, bring that on the screen. Why? Because now when I press this up, the circuit has the value of 1, which is to indicate that yes, this circuit is on. But the moment I'm not pressing it up, it's going to have the value of 0. So now this tells me that my computer can either process the state of 1 or a 0. Why can it only process the state of 1 or 0? Because you tell me, your light switch could either be turned on or it could be turned off. Like, is there any possibility that my light switch is neither on, neither off? Something in between? No, right? That does not even make sense. So like my light has to either stay on or it has to stay off. There is nothing in between. And that's the reason. That's the reason why when we study computer science, we talk about the concept known as binding, which is the method in which your computers understand every fundamental action. Now, everybody thinks that, okay, there are like these super duper code 10011010, those matrix and hacking sort of thing is, oh, by crazy difficult. But now, what it's totally all about is that when I say that something has the value of 1, this means that whatever the circuit we had, whether it was pressing the keyboard, whether that was my mouse having the click option. So like if I create a smaller mouse and I have this mouse button. So the moment you click upon this, whenever a student presses this part, when you do the right click, it's not like the computer is like, okay, bro, I felt it up here that it's a right click. Now, the computer has a circuit beneath that part. The moment you click on it, your computer is like, okay, that circuit has been turned on. So the moment your computer understands that it has the value of 1, it understands that, okay, that part is something which the user or the person is trying to click upon. And then when you click upon something, at the back end, the programmers have done some sort of programming that when you click upon this thingy or when this specific circuit has the value 1, you need to do this specific thing. And when the value is 0, you need to do something of, or like when the value is 1, you need to do something. And of course, if the value is 0, you do nothing. Why? Because it means that the circuit is off. So like if the switch is off, light on hone ki zarurat nahi hai, right? So if I have my lamp in front of me right now, if the switch is turned off, there is no need for it to be turned on, right? The light is only going to come up onto my screen, onto my face, only when what happens? When the circuit has the value 1. That's the reason why our computers only processes two states, which are what? Which are 1 and 0. And these two states of 1 and 0 are what we call as binary, which is basically the fundamental method of your computer understanding our actions. So the way I feel like, okay, light on ho gaya, light off ho gaya, motor on kar do, motor off kar do, bijli aa gayi, bijli chali gayi, oh mere game ka time ho gaya, mere game ka time nahi ho gaya, okay maine kitab padhni hai, nahi karni. All that stuff, computer doesn't understand that. Computer is like, okay, the value is 1, I need to do this. Value is 0, I don't need to do this. So that's the whole logic behind having 1 and 0s in your computers. Now, this is a very simple example for you all, that if you, before we jump into those bigger numbers, let's just talk about one switch. This is the light switch, right? So when I say that a specific switch is turned off, your computer does not understand that it's off. It basically interprets it as a 0. Which means that whenever all this computer of mine, it's not going to be made of a single circuit, right? There are going to be thousands of circuits. For example, you have this picture, right? All these components, every single thing which you see up here being interconnected with the other thing, that's basically a circuit. So all these cylindrical thingies, these square, these rectangular stuff you see up here in this animated image is basically a circuit. And let me tell you, you know what? Your computer is made up of millions of such circuits. Millions of such circuits. So what happens is that all these circuits are basically interconnected. And when a specific circuit is turned on, we are like, okay, this might mean that the switch is turned on. So when the switch is turned on, your computer is going to do that task. For example, if I say that you turn on the switch, the light is going to shine up. But your computer is not like, okay, light is on. The computer is like, okay, the circuit has the value 1. So when I say that a specific circuit has the value 1, this indicates that, okay, it has been turned on. And when I say that a specific circuit has the value 0, this means that the light or the specific circuit is turned off. So the next time we ever see in our world something like 1, 0, 0, 1, or like something like 0, 1, it's pretty much very evident for me that whenever I see the word 0, it means off. And whenever I see the word 1, it means on. Here are some other examples. For example, if I train my program in a way that there is going to be a circuit in my computer that when I press the button F would mean that, okay, turn on the fan. Okay, for example, there is this thingy in my computer that the moment I press the button F, it's going to turn on my fan. So it's not like when I click on the F button, my computer is going to understand that, okay, you turn on the fan. That's not how it works. The way it works is that when you click on the F button, it's going to turn on the circuit. So the circuit behind this fan, which we have up here, that is basically turned on. Why? Because it has the value 1. So now if I ask the computer, okay, buddy, tell me what's the value? Like, for example, I call the computer motherboard and I'm like, yo, CPU, buddy, what's up? Can you tell me the value of the circuit which currently fan is operating on? So my computer will not tell me something like, okay, bro, on or off. My computer would be like, okay, it has the value 1. When it has the value 1, it means it's working. When it has the value 0, it's off. Similarly, we might have a TV. So when I say that when I click on that remote control and I click on that on button, it's not like on button se kuch jadoo ho jata hai ki TV on ho jata hai. Nahin. The moment I click on that on button, the circuit within the TV, that has now the value of 1. The moment while the value of it changes to 1, the whole TV starts working. And similarly, when I click it again, the off button, it's not like the TV dies. It's like the circuit value is switched to 0. The moment it switches to 0, your computer is like, okay, tata, bye bye, easy scene, bye bye. Okay. Likewise, your phone and literally every circuit which is out there, it works in a similar way. It could either be turned on or it could be turned off. And that's the whole key idea. Your computer operates in pretty much very similar way. When some circuit which works on our computer is off, we assign it the value 0. And when I say that a specific circuit is being turned on, we assign it the value of 1. That's the reason your computer only understands 2 dimensions, which are 0 and 1. So next time you see those crazy wordings like zeros and ones, for example, let me even paste a picture up here. Binary. Let me just put some numbers. Yeah. So next time you see something like this, it's not for you to get worried. Okay. It's not like you should get worried. Okay, by hacking or by kya crazy scene ho raha hai na. All happening up here is basically different sort of circuits being turned on and off. So moment something pops up as 1, this means that, okay, it is 1. It is open. The moment it becomes 0, this means it's turned off. But now the problem is, right now up here, we have sort of created the model to be very easy, right? We said like, okay, 0 off, 1 on. But generally, we don't have it as 0 and 1. We have big numbers like 1, 0, 0, 1. Or we might have something like 0, 1, 0, 1, 0, 1. Or we might have something like the way you can see in this image, 1, 1, 1, 0, 1, 1, 0, 1, 0, 1, 1, 1, and so on, right? So now it's also important for us to understand all that stuff. Now, to understand that thing is, first baat to ye ki we understood that this 0 and 1 is what we call as binary. Why do we call it as binary? We call it as binary because this is the only state our computer can understand. So next time, guys, just give me a second though. Just give me a second. Just give me a second, guys. एक second दे दो. सुलेमान की कॉल आ गई थी, बट आपको all right, let's get back to it. Sorry for the small inconvenience. But yeah, you understand, right? The next time you hear binary, आपके ज़हन में clear cut होनी चाहिए that this is the language my computer understands. And what's the language my computer says? It's not hello, hi, my name is Mars. It's either 1 and 0, where 1 represents the on state for a specific circuit and a 0 represents an off state for a specific circuit. But now the thing is, our computers are basically made up of thousands of different circuits. Okay, so maybe I have a circuit number 1. This is circuit number 1. Okay, there might be a circuit number 2 up here, and there might be a circuit number 3 up here. And you know what? All these circuits which are within our computer, they're interconnected with each other. So if I go back to this small animation, you see everything is being interconnected. These small wires that you have, everything are like, something interconnected with each other. So every circuit which we have in our computer, they are either connected with each other through some sort of wire. क्या wire होती है, क्या चीजें बात की कहानी. For now, just understand the fundamentals. Now we know that all of these circuits could either be turned on or it could be turned off. Or I can in simple words say that it could be either having the value of 1 or it could have the value of 0. Likewise, it could have a value of 1 and it could have a value of 0. Now, the way our computers work is that, like, for example, if I have a computer system that works in a way that we have something like a fan up in front of me. So I have a fan in front of me. I have a TV in front of me. And for example, I also have something like maybe a lamp in front of me. And I'm like, okay, I'm a programmer who created this situation that this circuit is basically, when this circuit is turned on, it should only turn on the lamp. It should only turn on the lamp. But when I say that the second circuit is also turned on alongside the first circuit, then rather than turning on the lamp, it should then turn on the fan. And similarly, if I say that, okay, let's say you turn on all 3 of these switches, फिर उसकी जगह आप ना TV को open कर देना. So your computer sort of works in a pretty similar way, where what happens is all of these circuits, they are being programmed in a way, they are being taught in a way that when every single circuit is being turned on or off, उसके corresponding कोई specific action होता है. For example, if I say कि भाई light switch number 1 on हो जाए and बाकी 2 switches are off. So like switch number 1 is on, switch number 1 is on, and all the other 2 switches, like we might have another switch up here too, that's also off. So when the first switch is on and the other 2 are off, this would mean that you turn on a lamp. So when this is on, when this is basically turned on, then what you do is you basically turn on the lamp on. But then, as programmer, definitely you have seen, right? Your keyboard is used for so many reasons. You can type on the keyboard. You might press Alt F4 to close that up. At the same time, you might print print screen button to basically take a screenshot. So you see that same circuit which is beneath your keyboard is being used for multiple reasons. Now, how does your computer interpret all that? Or you might put Control C to copy or Control V to paste up. Have you ever wondered how within the same keyboard all this thing happens? So hota basically kuch is tarah hai that when you basically have multiple such circuits, when you turn on two circuits at once, for example, I say that, okay, you turn on the first circuit and you turn on the second circuit. So this will tell the computer that, okay, you turn on the fan. So in simple words, I might say that, okay, I have two switches in front of me. Or for example, I have this microphone in front of me. Assume that this is a circuit, okay? This is button number 1, this is button number 2. So if I press the first button only, like this button, this might only turn on the lamp. So like this lamp I have in front of me, ye lamp on ho jayega. But the moment I press both of the two buttons, it might open up a fan. So isse kya ho jayega? Isse, whoo, my fan has turned on. And so now I have an access to a fan. So now the fan is working. And similarly, what if I say that, okay, there are two buttons up here, but I also have two buttons up here. So if I, let's say, press two buttons up here somehow, and I press the two buttons up here, or like just one of them, which would basically mean कि यार कोई unique किस्म का और combination खोलो. So I can program my computer in a way कि जब मैं तीनों buttons को on करूं at the same time, when I turn on the three switches at the same time, this should mean that, okay, you now turn on the TV. So like if I, for example, turn on all of the three buttons, this would mean that you turn on the TV. And that is how your whole computer works. We have thousands of such circuits, thousands. Perhaps not even thousands, millions. Perhaps millions would be a good number, okay? We have millions of such circuits all interconnected with each other. And what happens is that when we interconnect all of them together, we say that, okay, when a specific thingy has the value 1, or like when it's turned on and baki off it to do this. When two circuits are turned on, baki off it, you do this. When all of the circuits are turned on and none of them are off, you do this. So with every specific circuit being turned on and being turned off, we program it to do a different set of action. So for example, if I look up here, if I just focus upon the lamp part, you can see one thing, that in the lamp, if I have to write the circuit numbers, the first circuit has what value? Because it's turned on. It's only for the, if I have to turn on the lamp, I need to only turn on the first circuit, right? Baki do to off honge, it has nothing to do with them, right? So if the first circuit is turned on, what's the value of the first circuit? It has the value what? 1, right? Because we said that if something is on, it has the value 1. If something is off, it has the value 0. So I can say that if lamp is turned on, it's going to have the value 1. But now you tell me at the same time, this 1 is for the first circuit. What's the value going to be for the second circuit? Because it's turned off, it needs to be what? It should be a 0. So I can say that the circuit 2 value is going to be a 0. Similarly, circuit 3 has to do nothing with the lamp, right? When we are turning on the lamp, it's like circuit number 1 is on, circuit number 2 is off, and similarly, circuit number 3 is also off. So this one is going to be 1, this off is going to be 0, and of course, the third circuit is also off, so I'm going to put a 0 for this too. So now my computer, when it understands and it sees the value 1, 0, 0, it's going to understand that, okay, circuit number 1 has been turned on, circuit number 2 and circuit number 3 are turned off. So now my computer is going to go into the memory part, into the programming section. It's going to see, okay, bro, what was I taught at the first place? That when 100 comes up, you should turn on the lamp. So the moment it sees 100, it's going to open up the lamp. Similarly, now if I have to look onto fan, I see for the fan, the first switch also needs to be opened up, and the second control switch also needs to be opened up. So I can say that, okay, I have the C1 that is going to be turned on, and at the same time, the C2 is also going to be turned on. But I see that I have nothing to do with the third switch, which means that the third switch is apparently going to be turned off. Okay, by the way, I don't know why I wrote this as C, this should be S, but yeah, I assume that the C1 is basically switch 1, okay? But yeah, now if I have to write this in terms of binary 0 and 1, how will I do that? It's pretty much clear forward. If something is on, I'm going to write it as 1. So I'm going to write that when switch number 1 is on, I'm going to write that as 1. Switch number 2 is on, so I'm going to write that as 1, 2. And switch number 3 apparently has to do nothing. It's turned off. So I'm going to put that as 0. So I can clearly see that I have created a set of command. Now when my computer understands that there is something like 110 coming inside it, it's directly going to tell it, okay, this means turn on the fan. Why? Because I know that switch number 1 should be turned on, switch number 2 should be turned on, switch number 3 should be turned off. Now, when this combination comes up, it's going to see, okay, when this person was, when Bill Gates was creating me at the first place, or when like Steve Jobs was creating me as the first ever MacBook or iMac, how did he program me? That when 110 comes up, this means you turn on the fan. And similarly, if I now focus upon the TV part, for TV, switch 1 should be on, switch 2 should be on, switch 3 should be on. So I can see that if I basically get C1 to be on, at the same time C2 to be on, and C3 to be on, this will basically indicate that I understood and that the whole thing has been turned on. So like when all the 3 switches are turned on, how will I depict that? It's going to be 1, followed by 1, followed by 1. So like 3 ones all together, indicating that yes, all of the 3 switches have been turned on. So now when my computer gets something like 111, it's going to open up the TV. So now these thousands of numbers you see up here, those are sort of following the same thingy that's happening up here. When the computer sees something like 100, it's going to open up something up here, which is corresponding to a lamp. When the computer up here sees something like 110, it's going to open up what? It's going to open up a fan. When the computer sees 111 up here, it's going to open up the TV. Similarly, your computer can have thousands of such lengthy binary codes. In our syllabus, we won't be going into that much depth. We're going to just understand the concept. We're going to see what's happening up here. But that's the basic fundamental concept of binary in your syllabus. And that is something which a lot of students usually do not understand, which is the reason why I'm trying to keep it very small. Once you understand why we have zeros and ones for our computers, I promise everything is literally going to be super easy. Now, this whole model has also been explained in this simple diagram for you, where I say that, okay, we can have 3 switches, switch 1, switch 2, switch 3. We know that when I turn on a specific switch, this would mean that it has the binary value of on, which is what? Which is 1. And when it is off, it's going to have a binary value of 0. So now if I say that I turn on a switch, it's going to have the value of 1. And when I turn it off, it's going to have the value of 0. So if there is a case 1 where I've programmed it beforehand that when you turn on only one switch and you keep the other 2 off, you're going to turn on the light. So for instance, you can see up here that when I turn on the switch number 1, I get the value to be as 1 and the other 2 to be as 0. Why 0? Because the other 2 switches are off. They are not turned on. And because the first switch is turned on, it's going to have the value of 1 up here. And when this happens, when this sort of combination happens where one circuit is 1 and the other 2 are off, you turn on the light. Similarly, if there is a case 2 where I have sort of told the computer beforehand that when 2 switches are turned on and the third one is off, you turn on the fan. So you see the same thing happens when I open the switch 1 and the switch 2 while keeping the switch 3 to be off. My computer interprets it as 1, 1, and 0. So when it understands and interprets everything in terms of 1, 1, and 0, it basically understands, okay, bro, this is basically talking about turning on the fan. And so it turns on the fan. But then if I turn all of them on at the same time, my computer interprets them as 1, 1, 1. And now it opens up the TV. So you see, we sort of have the same exact 3 switches, which we had up here. The exact 3 switches. But those 3 switches using the different combination of the circuits where one could be on, the other could be off. One could have the value of 1, the other could have the value of 0. By changing this on and off state of these 3 switches, we could see that we are having a different output at the end. One output saying light on, the other saying fan on, the third saying TV on. So this is how your computers generally work. Your computers are sort of created similarly using millions of such circuits, where every circuit could either be turned on and off. Because it could only be either turned on and off, and there is nothing other possible than on or off, we say that your computer can only understand 1 and 0, where 1 would mean that it is turned on and a 0 would mean that it's a turned off. And this language of 1s and 0 is what we call as binary, which is the sole language my computer understands. Why? Because my computer is created of circuits, and a circuit could only understand on or off. Hence, that's the fundamental introduction into the world of binary. And that is why we always say कि computer सिर्फ zeros and ones को समझता है. I hope this understanding is somewhat clear. If there if you guys still let me know somehow कि कुछ समझ आई है तो बता दो. We can open up this message box for a second. So if it's clear, let me know in the text box so that we can move on. But I hope you now understand the fundamental reasoning behind why we have zeros and ones. Perfect. That's so great to know. MashaAllah, MashaAllah. Perfect. So I sort of explained this in very slow and detailed because I want कि आप लोग को ये चीजें अच्छी से समझ आए. The moment you understand this in the right way, everything ahead would be easy seen. Okay. All right. Perfect. Let me just close the chat box again, but perfect. All right. Now let's move on. So now we have understood the basic logic behind having binary in our syllabus. Okay. So now we know okay, computers have circuits have blah, 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 blah stuff. But now we need to understand what are the type of systems or the way a computer can understand the data. So we saw that the first topic which we are jumping into today, it's regarding data representation, which basically means that when I say hello, when I say hi, when I say mera naam Maaz Munir hai, how does my computer understand all of these different languages? How does it represent the data within itself, despite it being just a circuit? And that is why we are going into the concepts of number system, which is basically to see how can my computer understand data? So the very first type of number system in our syllabus, it's basically known as binary, which we just saw. So we can see that a binary is basically a type of number system that can only have two possible values. Two values. What are those two values? It could either have the value 1 and it could either have the value 0. It cannot have something like 2, 3, 4, 5. A circuit could either be on or off. So 1 or 0. And in computers, when we want to tell how many type of values it could have, we use a keyword known as base. So a binary is basically a base 2 number system. What do I mean by base 2 number system? Base 2 number system basically means that it can maximum have two possible values. So it could either be 1 or it could be a 0. So next time you hear the word base, आपको पता होना चाहिए कि base 2 basically means that it could have two values. Similarly, if I say something is like base 10, this means it could have 10 possible values. But in the case of binary, it's only base 2 number system, where it could be either having the value of 1 or 0. But now, there is one problem. Generally, if I'm talking with each one of you and I ask you to tell me some number, so you might say something like 5, or you might say 7, you might say 8. We usually do not talk with ones and zeros, right? We have something like a conventional number system, and a conventional number system that basically operates on digits from 0 to 9, right? Number system. We have a conventional number system that basically works all the way from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And so on, it continues. Like, if I say that, I scored 98. So 98 may say 90 comes up from this list and 8 is also from this list. So any number which we create in our day-to-day life, like aapko main koi bolun that you create a number for me, that number has to take digits from this list. There is no possibility that a number is being formed up in our day-to-day life, which comes out from something out of this list, right? So such list, which we generally, personally, humanly use, that list is basically known as Denary, which is the second number system. Now, we don't call it the conventional number system, but for you to understand it, just know that when we have to talk about the conventional number system or the number system we humans understand, that in the world of computer science is known as Denary. And now your Denary could have how many values? It could have basically 10 values. It could have 10 values. What are those 10 values? They are from 0 to 9. So if you count them up, you might be wondering, sir, ye to 9 honge, nahi 9 nahi honge. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 values, which means that the way I mentioned up here, कि यार भाई आपके binary is a base 2 number system just because it has two values. What does this mean? What is Denary going to be in that case? It's pretty much evident that if base tells me how many possible values it could have, this means that Denary is going to have 10 possible values, 0, 1, 2, 3, 4, 5, 6, 7, and 9. So this means Denary is a base 10 number system. So when I say that something is a specific base number system, like for example, I say base 10 number system, what does this mean? Base 10 number system means that, okay, it's a specific type of number system which is used by the computer to represent the data, and it could have 10 possible values. So this number system, I forgot to define it out, but number system in simple words is like how I can display the numbers. How can I display the numbers? How can I display the numbers? Okay. So if I say that I'm making use of a base 10 number system, this means that I'm trying to display numbers using possible 10 digits. What are those 10 digits? 0 to 9. If I say that, okay, I'm making use of base 2 number system, which is basically a binary number system. So I'm trying to display numbers using 2 possible values. What are those 2 possible values? 0 and 1. And similarly, we also have a third number system, which we're going to discuss inshallah ta'ala tomorrow. For now, we won't be jumping into it. Perhaps what we're going to understand is that as computer science people, it is something you all should be proud of. By normal, these bio people or students who are non-computer science students, they only are confident to write values in terms of Denary, right? If I ask one of you, कि भाई आपके 10 में से कितने marks आए थे, you might say, okay, sir, I got 9.5 out of 10. Okay, I got 9.5. So 9.5 is something which is within this grade. 9 यहाँ से आ गया ना, so you get 9.5. So it's a conversion number system. But what if I tell you that we have something crazy coming up in our classes? What if I tell you that, okay, if I'm born on the 16th of September, what if I convert this 16 into binary? Isn't that going to be fun? What do you think? Isn't it going to be fun if I'm able to convert the Denary number system into something like binary, where everything is going to be in zeros and ones? So that's the very fundamental thing which we're going to be studying in our syllabus, that how do I basically convert by a Denary value to binary? So converting Denary into binary. So if I want to convert a specific number into binary format, where I want every single thing to be of zeros and ones, you need to understand one thing. You know what? Understand आपने कुछ इस तरह की चीज करनी है, that if I have to write a specific number, like let's say 7,653, back when we were learning mathematics for the very first time, back in grade 1, grade 2, grade 3 की कहानी है, you would recall that our teachers taught us something as ones, tens, hundreds, and thousands, right? मुझे बताया गया था ना, which was created for what reason? It was created for the reason that, okay, if I have 1,000 numbers, so like if I have to divide this, if I've been given a large number, like for example, 8,253, so I'm going to convert it into that this 8 is basically of the 1,000 form, right? That it's basically creating 8,000, then we have 200, then we have 50, and we have 3. So when I add all of them separately, it's going to create 8,253. So what happened was, कि हमने देखा that every single slot, when I'm trying to write a digit, it's having a specific value. So like this specific position number one is just carrying the values of the 1 digits. Position number 1, you see, it's storing the value 3. Position number 2 is basically storing the values of the 10. So like 5 is basically at the 10 spot. So 5 multiplied by 10 makes it this 50. Then I see that this 6 is basically this, which is position number 3. This is at the 100 spot. So like 6 multiplied by 100 makes it 600, which understands, okay, 600 ye bane. And similarly, position number 4 is storing the value of thousands. So this 7 is not the normal 7. This 7 is basically of 7,000. All thanks to what? All thanks to this artificial value of 1,000 being assigned to this position. Similarly, your computer also operates in a very similar manner. You know what? Your binary, whenever I want to convert from Denary to binary, you follow a pretty similar logic. But the problem up here is that this system is the conventional number system. And we know that the conventional number system has how many base? It has a base 10 number system. Now to find the value of each position, like यहाँ पे तो हम ones, tens, hundred, thousands करें. You know what? If I have to find the value of each position, position 1, position 2, position 3, position 4, there's a mathematical formula for that too, जो कि हमें कभी पढ़ाएंगे. You know what? What's the formula? कोई याद करने की जरूरत है. It's not something you need to memorize, but for your own understanding. The formula is something like value being equal to base raised to power position. Okay, base raised to power position. This is a formula I myself created. It might be a formula though, but I sort of came up with on my own when I was teaching students. So I don't know if it has been drafted ever before. Well and good. If not, then this is Mars Muni's formula for calculating the value of at every position, right? And what's happening up here is that right now I'm saying that this is 1, this is 10, this is 100, this is 1,000. What if I can prove it to you? Let's try to prove it up. You know what? Your computers, if I have to start counting, what's the very first number in our world? We generally think that the very first value, whenever I have to start counting, whenever I have to, take number of bytes or whatsoever, you always start from 1. So I might be like, okay, I have a few pencils. So this is pencil number 1. This is pencil number 2. Let's say this is pencil number 3, for example. So we always start off with the value 1. But you should understand one thing, that your computer does not start from 1. Your computer has been taught that the very first thing ever introduced in the world of computers is a 0. So your computer always starts the very first position, the very first index, the very first counting, the very first iteration or whatever, like the very first thingy from the value 0. So jab hum bole ki okay, this is the 0th thing, this is the first thing. So your second thing is apparently the first thing. Why? Because your computer starts counting from 0. So 0 thing, first thing, second thing, third thing, fourth thing, and so on. So based upon that, if I have to calculate the value up here, this basically comes out to be, if I rename the positions, this is my position number 0, which is the very first position. This is position number 1. This is position number 2. This is position number 3. So now if I have to find the values for this, let me do it for you. So what's the base? This is the convention number system. So convention number system is the Denary one. Denary we all know is base what? It's basically base, it's up here. So it's basically base 10. So if I have to write that formula up here, 10 raised to power 0 is what? 10 raised to power 0 is 1. So I say ones come up from here. You see, that's the reason we call this position to be ones. Then let's do it for the second one. 10 raised to power 1. That's what? That's 10. That's the reason we call the second position to be as 10. Similarly, we go to the second position, the third position. 10 square is what? It's 100. That's the reason we call the third one to be as hundreds. And similarly, 10 raised to power position of 3. So 10 raised to power position 3 comes out to be as 10 into 10 into 10. So 10 into 10, 100, 100 into 10, 1,000. So that comes out to be as 1,000. And you see that using this equation, we prove how you generally basically get the value 1,000, 100, 10, and 1 up here. But now you might be wondering, sir, ये सब यहाँ पे discuss करने की ज़रूरत क्या थी? So the logic behind introducing this was that the way we generally, for the purpose of normal convention number system, have a logic like hundreds, tens, ones, and thousands, your binary, because binary is not the normal convention system, it also has values for specific positions. So we say that if I have to basically convert something from binary to denary, we will also have similar positions. So we might have a position like 0, 1, then this, then this, then this, then this, this. So, you know, sort of empty boxes. Empty boxes. In your syllabus, the maximum number of empty boxes you would be dealing with are 8. So like this would be what? This is position number 0. This is position number 1, position number 2, position number 3, position number 4, position number 5, position number 6, position number 7. So if I have to sort of give you a quick summary, what we are sort of creating up here are basically 8 positions. And now the thing is, all of these positions, just the way we saw that up here, each of the position have a specific value, like this has the value 1, this position has the value 10, this has the value 100, this has the value 1000. It's not like iski koi values. It's basically when I have to convert it up, this 3 is basically multiplied with 1 to become 3 plus This 5 is multiplied with 10. So 5 multiplied by 10, 50 plus this 6 is being multiplied by 100. So 6 multiplied by 100 makes it 600. And plus that 7 is being multiplied with 1000 to make it 7000. And when I add all of them, I get 7653. Similarly, when I have to convert something into binary, your binary also stores the values in a similar way, but every position has a different value. And now what's the value of each position? That is something we will again calculate using the same position, the same formula. So like, for example, let's start off with the very first block up here. Remember, whenever you talk about storing numerical values, you always start from the most right-hand side. Oh, my bad. Yeah. So you always start from the right-hand side and you go towards the left. So you always start from where? You start off from the right-hand side. So when writing digits, you write the smallest one at the most right. The ones is always at the most right-hand side. Similarly, when you write something in binary, it also has to be from the most right-hand side. Now let's try to calculate the values. 2. Now you tell me, what's the base of binary? This right now is binary, right? Binary, we clearly saw, could either have 1 or it could have 0 as its value. When it could have a value of 1 or it could have a value of 0, this means it has base 2 as its value. When it has the value of base 2, I can put 2 up here and then I'm going to raise to the power of the position. So 2 raised to the power of position 0 is basically what? 2 raised to power 0 is 1. So I say that the very first one up here has the value 1. Moving on, the second block up here will be having the value of what? 2 raised to power 1, which is basically 2. So this comes out to be having the value of 2. Then similarly, 2 raised to power the third block up here, which is basically position number 2. So 2 raised to power 2 is what? It's basically 4. So I say that the third block up here has the value 4. Similarly, the third position has the value 2 raised to power 3, which is going to be what? Which is going to be 8. Then I see there is the fourth position. So 2 raised to power 4, which is going to be 16. And if you even identify the trend, you can clearly see that it's basically getting doubled. So it's getting doubled, multiply by 2, and so on. So like if I continue it up and I see that the next one is 2 raised to power position number 5. So position number 5 makes it a 32, which is again the double. Similarly, if I do it for position number 6, 2 raised to power 6, that makes it to be as 64. This has the value 64. And then I have the position number 7, which makes it to be as 128. And now I have 128 up here. But now you might be wondering, sir, okay, ye to samajh aa gayi. I now have 8 specific slots and I have basically 8 different positions, and each of those positions have a different value. For example, I might even convert this into blocks. So like to make it a bit more neater, let's convert this into a block, a big block, okay? So now I know all of them have a different value. So this has the value 1, this one has the value 2, this value has the value 4, this has the value 8, this one has the value 16, this one has the value 32, this one has the value 64, and this one has the value 128. But these values are in conventional number system. Now you won't write 7, 6, 5, 3 up here, but rather we are only going to write zeros and ones. So in sections we could either going to put a 0 or a 1, but we are going to put 1 under all those places, which when I add them up, I should be getting the specific number. For example, if I have to give you a quick example, let's say I want to put the number 80, or like rather, let's make it easy. I want to put the number 25. So I'm going to put 1 under all these values, where when I add them up, I should be getting the answer 25. For example, 16 ke niche when I put 1, it's going to denote that, okay, 16 plus what other things will I be adding into 16 so that I get my answer to be as 25. 16 plus 8 is what? 16 plus 8 is 24. Okay, I get 24. 24 plus what should be added to make it 25? 24 plus 1, right? So if I put a 1 under all these sections, this will tell the computer that, okay, you are trying to represent the value where this value is being added up, this value is being added up, and this value is being added up. And we can clearly see that the values, these three are 16 plus 8, which are 24 plus 1, which makes it a 25. So I sort of converted the value 25 into binary by writing 25 in terms of ones. But then you would be like, okay, sir, जो बाकी जगह वहां पे आपने कुछ put ही नहीं किया. Where what happens in the other slots? So you just put ones under the places which when you add up you get the number, and in all the other places you just put a 0. 0, 0, 0, 0. So you can clearly see up here that what we sort of just implemented up here was a logic method which ensured that now this is my binary for the number 25. So for number 25, I get my binary to be as 0, 0, 0, 1, 1, 0, 0, 1. To give you a quick recap of what we did, we sort of saw that every value up here, every position is going to have a unique value. It's similar to saying that every place in the binary placeholder, like assume that all of these places are like columns, a specific box. Every box is going to have a different value. Let's say our Monopoly, if anybody of you have played the Monopoly game, you can see we could have one notes, we could have $5 notes, we could have $10 notes, $20 notes, 25, 30, 50, $100 notes. So we have like multiple notes. So ये उसके अंदर it's similar to that bank model where every position has a different value. Every position has a different value. The first one has the value 1, the second one has the value 2, 4, 8, 16, and so on up to 128. And now if I have to represent a specific Denary number in terms of binary, I'm going to put 1 because 1 indicates what? Yes, bhai, isko add karo, make this circuit as 1. So if this circuit has the value 16, this circuit has the value 8, this circuit has the value 1. So when I turn on 16, 8, and 1, your computer interprets it as 16 plus 8 plus 1, which makes it a 25. Similarly, if I give you a quick another example, and then I'm going to take a few questions before ending the class. For example, if I make up another scenario, we have boxes like 1, 2, 3, 4, 5, 6, 7, 8. What are the values we calculated up there? It's going to be 1, 2, 4, 8, 16, 32, 64, 128. ये over time खुद याद हो जाएंगे, अभी कोई परेशान नहीं होना, but it's basically 1 followed by 2 and multiplied by 2 every time. Okay, so it's 2 being multiplied everywhere. And now if I have to write some number like, let's say 37. So how can I write 37 up here? I'm going to put 1 under all those values, which when I add them up, I should get a 37. For example, 32 plus what will get me a 37? 32 plus 5 will get me a 37, right? So 32 plus 5. So now I need to put 1 under all those places, which could get me a 5. So how can I get a 5 from all this? 4 plus 1 will definitely get me a 5, right? So if I do this, 32 plus 4 plus 1, I see that I get the answer to be as 37. And the way I told before that, okay, if I convert it and place the ones in the right place, all the other places are basically going to be filled up with zeros. Which means कि okay, भाई आपकी जरूरत हमें नहीं है, हमें जिनकी जरूरत थी वो हमने avail कर लिए. The people who we required for the purpose of converting the Denary number into binary, we made use of them. So we don't need you, so just stay off. Okay, bye, bro. We don't need you. Just stay off. Chill, buddy, chill. I've already talked to the people who can get me the answer as 37. And there you go. So your number 37, if you want to represent that in binary, that is your answer. 00100101. So you can see this answer right now is in binary. Why is it in binary? Because it's base 2. Why is it base 2? Because it could either have the state of 0 or 1. Do you see any 3 or a 7 up here? Do you see any 2 or a 9 up here? No, right? All you see is zeros and ones. So we successfully converted something which was in the Denary number system, and we converted that into the binary. Now, your small practice for today would be that the day of birth on which you were born. So like I was born on the 16th of September. So if you were born on whatever date you were born on, it's your task that you sort of convert that specific number into binary. And then you may let me know about that tomorrow, inshallah. Okay, but that was the whole concept about understanding what binary is, how your computer processes it, what's Denary, what's binary, and how you can convert a Denary number into binary number system. Now I'm opening up the chat box. Okay, I want you guys to let me know if it's clear or not. If there are any questions, aap aaram se poocho, maine kahin nahi jana, main idhar hi baitha hu. If you do not understand it, again let me know so that I can re-explain the whole thing. Okay. So yeah, the chat box is now open. So if there are first any questions, so questions पूछ लो. उसके बाद if there are any other things, तो हम बाद में discuss करेंगे. Okay. So is Denary and decimal the same? Yes, they are the same. But according to your syllabus, it's Denary. Okay. So it's better to go with the one which your syllabus is sort of explaining. आप syllabus जो चीज बता रही हो उसके साथ जाओ, इससे उधर उधर जाओगे तो confuse होगे. But yeah, Denary decimal is the same thing. MashaAllah, that's so great to know. That's so great to know. Would we get digital notes? Of course. Sir, here later homework. Kya baat hai, kya baat hai, kya baat hai. Sir, isn't it easier by LCM? Ravi, I'm going to come on that tomorrow. The methods which I'm trying to share with you all up here, these are the methods. These are the methods which are sort of explaining you all the concept in similar easy ways. So let me just turn it off. So there is one other way of converting Denary into a binary 2, and that's the LCM method. Now, I personally do not recommend the LCM method. वो मैं बता दूंगा, but you know what the LCM method says? It says that, okay, there is a number like 25. You keep on dividing that by 2, and then the remainder you get based upon that, you set a 0 and 1. Now, the problem is if there is some dumb person like me who says that, okay, 25 divided by 2 is 13. So, भाई मैंने तो blunder कर दिया. I made a mistake. So, if I make a mistake like this, your whole answer is going to get wrong. And even though you might make it because you were not sleeping well, तो वो काफी बड़ी गलती हो सकती है. So to avoid the chances of mistake, throughout my classes, I'm going to tell you if there are alternate methods to something, but the method which I'm going to share with you all, those are the methods which have the least chances of errors being created. And these methods are 100% approved by your examiner. So if you use this method, you can clearly verify your answer easily. Like rather than making use of the LCM method where you're rechecking again and again, and you're just confusing yourself. I don't want my students to be confused. I don't want any one of you to be confused, which is why if you enroll with us, I'm only going to be taking you through the methods, which is going to ensure that you understand the concept in the least amount of time, get to the answer as fast as possible with the least amount of errors out there, which is this method. Okay, but of course there are other methods जो कि हम discuss करेंगे, but वो मैं बताऊंगा कि this method exists, which if you want to do it, well and good, but मैं recommend नहीं करूँगा. सही है? Okay. So please now explain how would we know how many powers of 2 to write. How many of powers of 2 in terms of this, how many positions we are going to have. So आपके syllabus में the maximum you are going to inshallah be dealing with are 8 positions. So most of the times you're only going to be dealing with these 8 positions. So you're going to go from 2 raised to position number 0 all the way position number 7. Like basically it comes out to be as position number 8. So 8, 7, 6, 5, 4, 3, 2, 1. Okay. So the maximum you're going to go is till this position. That's the reason why I'm sort of keeping it till this point. And आपके सारे के सारे यही होगा. So what syllabus are you following, sir? I'm following both the IGCSE and the O-level ones. But if you want to convert a big number, we're going to do that tomorrow. Okay, so we're going to do that. So if examiner says to solve it, the examiner will never say to solve it using the LCM method. Sir, can we use binary to represent non-integer? Yes, you can, but that is something we're going to study in A levels, inshallah. It's not something which can come up in O levels, okay? A levels concept. And to be very precise, it's going to be something you're going to learn in A2, inshallah. So in the light and fan example, if we directly turn on the switch 3, then nothing would turn on, right? Yeah, you're correct. So it's sort of, we didn't create the scenario, but given that in 3 cases में nothing is happening, तो कुछ नहीं होगा. So if you just turn on the switch 3, यहाँ पे तो हमने कोई इसको coding नहीं की ना, but अगर कोई code हुआ होगा कि switch 3 को on करके, let's say you turn on the heater. So whatever is being coded, उसी लिहाज से होगा. So in this case कुछ नहीं हुआ, तो कुछ नहीं होगा. सही है? हाँ. So what topic should we keep most under or radar during this class? Whatever I'm teaching, बस उसको समझो. सही है? So the answer after conversion, देखो ये बात की कहानी है राबिया, something which is a bit detailed, उसके ऊपर मैं आऊँगा when we are solving the exam questions. For now, just understand the question. Should we just रट्टा 2 की powers? Of course. इसमें कोई रट्टा की बात है भी नहीं, you know. It's बस आपको ये ज़हन में आना चाहिए, आपको concept पता होना चाहिए. I want you all to understand the concept. You know what? These normal teachers which we have here and there, if you open up the book and like I've seen numerous teachers, including जो मेरे साथ हो रहा था, I never get to know कि okay, why does this value come up? Today you understood why and where 1, 2, 4, 8, 16, 32, 64, 128 comes from. So now if anybody asks you, okay, भाई, where does this 1, 2, 4, 8 come from? तो आपको पता होना चाहिए, आपको याद होगा, सही है? But yeah, that's everything जो कि आपको अगर आपने याद करना है तो आप इजीली याद कर लो, कोई मसले की बात नहीं है। सर लिमिट इज 128 राइट, नहीं आप आगे बढ़ सकते हो, वो आगे जब हम क्वेश्चंस करेंगे तो उसमें आपको फर्दर समझ आएगी। बट फॉर नाउ ओ लेवल के कॉन्टेक्स्ट में द मैक्स मोस्ट ऑफ द टाइम्स लाइक 90% ऑफ द टाइम्स यू कैन गो टिल 128. You have to remember the table. Baki Gani, Krishna, we're going to discuss that once we get to hexadecimals, inshallah. So, the syllabus for IGCSE and all 100% same, fully same. Koi fark nahi. So, when will the class get over? So, it's over. It's over. You can leave if you have no question. What's the LCM method? It's a confusing method, jo ke gets you to the same answer. I would advise leave it. Say ye koi zarurat nahi usko samajhne ki. सर इन केस ओनली वन स्विच इज ऑन व्हाई नॉट, ये तो वैसे ही अजान मैंने सिनेरियो बनाया था ना, मैंने सिनेरियो से सपोज किया था, इट्स नॉट लाइक कि कोई हमेशा इस तरह होगा, ये तो आपको वैसे ही समझाने के लिए मैंने बताया था कि अगर एक स्विच ऑन हो गया तो ये होगा, दो हो गए तो ये हो गए, तो इट्स नॉट लाइक कि कोई हमेशा ये हो इसी तरह होगा, इट्स फॉर योर ओन अंडरस्टैंडिंग. सही बात है ईमान, आई एम वेरी बैड एट फाइंडिंग एलसीएम, यू करेक्ट, that's the reason I don't advise. So like literally if I'm bad a lot of people are also bad. Okay, so if people are bad तो फरमान भाई अगर आपको बोझ हो कि आप खुद कर लो तो कर लेते हैं. You need to tell me the answer for that question. Okay, we can do that tomorrow. Thank you so much Zaria, I really appreciate it. But that's it. So any other questions or did you understand it the right way? कोई भी और सवाल हो तो पूछो guys, I am here for you all. How did you have a glow up? I did not have a glow up. Glow down ho gaya tha. Thank you so much. Okay, Ishal already did it. Let me just see it. So that's going to be 64 and then that's going to be 60. Yep, that's correct, Ishal. All right, that's super great to know कि आप लोग को अच्छे से समझ आ गई. Inshallah, tomorrow we're going to be having need to watch. Yes, no, it's you don't need to watch any lecture though. उसके अंदर we just covered up कि यार कोर्स में होगा किस तरीके से, क्या सिस्टम होगा, किस तरीके से क्लास कंडक्ट होगी, कब होगी, ब्ला 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 स्टफ, एंड सिलेबस को ओवरव्यू किया था और कुछ इंपॉर्टेंट चीजें नहीं थी. बट इफ यू वांट टू वॉच इट आप देख लो. Tomorrow inshallah we're going to be having our last demo class. For all those interested in joining our session, you may reach out to Miss Naiba. For the people who might be saying कि okay Miss Naiba ने जवाब नहीं दिया तो she's going to respond inshallah कर लेंगी. If not you can of course drop a DM again, but that's a number 92318177201. Let me confirm bro, मैं भूल जाता हूँ यही है भी या नहीं. Let me confirm it too. I guess it's this. So 9 कहाँ से आता है number 1772015. Yep, that's the number. That's great to know, Shay. The zeros before the one necessary to go. Okay, the zeros before the one basically indicate कि यार यहाँ पे कोई इसकी जरूरत नहीं है. So all the places which we are not using, like all the places which we are not using, like देखो हम 64 को कहीं use कर रहे हैं नहीं ना, 128 को कर रहे हैं नहीं ना, 16 को कर रहे हैं नहीं, 8 को कर रहे हैं नहीं, 2 को कर रहे हैं नहीं ना. All the places जो कि हमें चाहिए to get the result, उधर हम 1 put करेंगे and उसके बगैर जो हमें नहीं चाहिए उधर हम 0 put करेंगे. So all the places which are not required, we're going to put zeros there. Sir, is taking 2 subjects for this year, October, November? Yep. दो के साथ I would perfectly say 2 is perfectly fine. Will we continue from where we left off? Yep. So we're going to continue from here, inshallah. Thank you very much, and inshallah, Faris, you're going to do super well. And June 1 will start from beginning again. No. We're going to continue from jahan tak humne kar liya demo classes se, and after that, once the demo class period ends, the next official class would be inshallah ta'ala from the 8th. Okay, so it's not going to be from the 2nd. So we're going to have 3 demo classes. फिर 3 दिन आपको सोचने के लिए दिए जाएंगे. आपने अगर कोई सोचना हो, कोई सवाल हो तो पूछ लेना. And inshallah, then from the 8th, we're going to continue it out. That's perfectly fine, Dua. Bilkul. Dua, your answer is 0000010. It shouldn't be that. For 4, it should be 00000, and ye 4 should be 1, right? So ye 1 hoga and baki sab 0. So that should be. Okay? Yes, exactly. Bilkul. Do you understand, Dua, why it should be a 1 up here? अगर देखो 4 की वैल्यू तो यहाँ पे 1 होनी चाहिए. So that's the reason, क्योंकि हमें 4 ऑन करना है, राइट? बाकी सारे तो हमें नहीं चाहिए. So that's the reason we only put a 1 up here and all the other places are kept 0. So it's binary of 14 this. So let me see. This is 8 plus 4, 12 plus, yep. Yes, Khatija, perfect.
Well, all right, everybody, that is it for today. It was a lovely class, and I hope you guys had a good chance of learning what binary is and how the whole thing works. See you guys, inshallah, tomorrow again at 9 p.m. And of course, we'd love to have you all in the classes too for the registered kiddos. Take care and Allah Hafiz.